Welcome to this video of applied electricity. We are going to be doing our superposition theorem. So we have this question here with two voltage sources, and the definition of superposition theorem is that the theorem states that the response of a linear network that is containing either voltage source or current source is the sum of the response of each source taken in turn, with the voltage source short-circuited and the current source open-circuited. So when you are using a current source to solve for a particular entity, maybe current or voltage, you are going to open-circuit it. Then when you are using voltage source, you are going to short-circuit it. So as you can see in the question, we have two voltage sources. So all what we are going to be doing here is what? Short-circuit. So thank you. So um, this is the first part we are going to be using. We are using this one first, the voltage 2.05 volts. We are using that first. So while we are using that, we are going to short circuit the second voltage. When we are dealing with voltage, we are short circuiting. So that's what we did here, and we have this diagram. So when we are through with this, also we also come here. We will make use of the second branch, the second voltage, and we are going to short circuit this, the one here. That's why you cannot see any voltage here again. So let's move on. First thing to do is to calculate the equivalent resistance. So when you are calculating the equivalent resistance, you mind the one in parallel and the one in series. So this 1 ohms is in parallel with this and is in series with this. Why? This one 0.05 ohm is holding the voltage. So this and this are taken in relation, then in series with the one holding the voltage. So what are we having? We'll be having equivalent resistance. One is in parallel with 0.04, then plus 0.05. So when you calculate that, you have 1 times 0.04 over 1 plus 0.04, then plus 0.05. That will give us, when we calculate that, our equivalent resistance is 0.089. 0.089 ohms. Now we have the voltage, we have the resistance, we need the current. So if we look for the current, V over R. So this is our V here, 2.05. Then our R is one we got now, 0.089. That's the equivalent resistance. So when we calculate the value for voltage, we are going to be having 23.17 ampere. So that is the voltage, that is the current flowing through this place. So and we need the current. The question was to find the current through the 1 ohm resistor. So this current that we got here is going to split into two. One is going to come here, one is going to come here. So that means we are using current divider. And how do we do that? To get the current flowing through this place, it's going to be current in 1 ohm. We are using the total current here, which is here, total current 23.17 multiplied by the other resistor. No, we want to find the current in this resistor. The other resistor, which is 0.04. The other resistor you are using in relation. So plus the sum of the two resistors, that's 1 plus 0.04. That will give us, if we press on our calculator, we should have 0.891 amps. So now we are getting for this part. Now let's move to the second part. With the first voltage source short circuited and the second voltage source in use, we have 1 ohms here. So now first thing also is to calculate the equivalent resistance. So now this time around it's going to be this and this in parallel, then in series with the one holding the voltage. Do we get? So now let's move on. This and this in parallel, one in parallel with 0.05, then in series with 0.04. So what this one we have? And we calculate that on our calculator. We are going to be having an equivalent resistance of 0.0896, or am I correct there? Okay, 0.0896. 0.0896 ohms. Now we need the current. We have the voltage. This is the voltage. We have the resistance. So we need the current. So current is going to be V over R. And what is V? 2.15. Then what is R? The one we got here now. 0.0896. So what will be our current in that place? Our current, so it should be 7, 0.876, not 9. 0.876. So this is 7 here. So our current here will be, we've gotten our current. Our current there should be 24.54. 24.54 ampere. But we do remember that we need the current in this. So we are going to use another current divider. The one current to flow through this place, one current to flow here, and one current to flow here. So we are using current divider. I'll just say current in 1 ohm resistor, just like the way we did here. The total current 24.54 multiplied by the other resistor, this, over the sum of both, 1 plus 0.05. So, and that will give us, let me calculate that on our calculator. Your 1 ohm resistor will be 1.169 amps. So yes, we now get the algebraic sum of both. So you just say current in 1 ohm, that's the total, that's the algebraic sum now, will be 0.891 plus 1.169. So that's going to be 2.06 ampere. So we can see that it's a very, very simple process. That's all for this part. Thank you very much. So we are still going to be releasing more videos on exam-based question. This is an exam-based question, so we have to practice more of this. If you also have a question that you are feeling you don't understand, you can post it on the comment section, and we are going to go through it. Thank you very much.